Alright, I'm asked to find dy dx, so I know this is implicit differentiation because I have some y's in here. Remember, any time that you have a variable different from what's on the bottom here, you have to follow it with the dy dx after you take the derivative. So the derivative of the first term would be 6x squared. That's with respect to x, so I don't have to do anything with that. This piece right here is actually a product rule, as well as that one. So the product rule says leave x squared alone times the derivative of y, which is 1, but then I have to follow it with dy dx, plus take the derivative of x squared times y. So that's this product rule. Minus, I'm going to put this in square brackets so I don't miss distributing the negative sign. Leave the x alone times the derivative of y, which is 3y squared dy dx, plus the derivative of x, which is just 1, and leave the y alone. And then the derivative of 2 is a constant, so that becomes 0. So the next step is I'm going to take, and that's this product rule. The next step is I'm just going to distribute this negative sign. So I'm going to have 6x squared plus x squared dy dx, put that together, make it look a little better, plus 2xy minus 3xy squared dy dx. I'll just move the x inside. And then minus y cubed because I'm distributing that negative sign. Then everything that has a dy dx I'm going to leave on this side because that's what I'm trying to solve for. 3xy squared dy dx. Everything that does not have a dy dx, I'm going to chunk it to the other side. So when it gets chunked, the sign changes to xy and then plus y cubed. And then I'm almost home free. So I'm going to factor out a dy dx. So that leaves me with an x squared minus 3xy squared. And I just still have the same thing. I didn't do anything on this side. And so finally, since I factored out the dy dx, I can now divide both sides by this x squared 3xy squared, because that cancels and I now have solved this for dy dx.